Okay, in this video lesson, we are going to be taking a look at the concept of completing the square. And we're going to be using that to convert from the standard form of a quadratic function to the vertex form. So here's your standard form, y equals ax squared plus bx plus c. And this is your vertex form. And again, the reason it is called vertex form is because this form gives us the vertex. The maximum or the minimum of the quadratic function is at hk. So we're going to convert from this standard form to the vertex form by using the concept of completing the square. So we're going to look at a couple examples that we might see on our assignment. Okay, so in this first problem, we're given this equation, y equals x squared plus 10x plus 8. This is a quadratic function, and it's asking to write it in vertex form, and this is currently in standard form, ax squared plus bx plus c. Now, I'm going to start by writing this as an equation, so x squared plus 10x plus 8, and I'm going to set it equal to 0, okay? Now, we're going to complete the square, but the part that we're going to use to complete the square is this first part, the ax squared plus bx, all right? So that means I'm going to take this c and remove it, I'm going to move it like to the other side, okay? Or another way to think about it is equation, I would subtract 8 from here so that we could cancel it, but I have to subtract 8 over here. So now my equation says x squared plus 10x equals negative 8. Okay, so we're going to complete the square with this part right here. We're going to turn it into a perfect square that has the factor, okay, of a perfect square. So this is the b term. The way that we complete the square is that we're going to add a term to both sides, and I'm going to write this square on both sides to identify that I'm completing the square. And what goes in here is always half of the b term squared. So I'll write that over here. It's always half of the b term, so b divided by 2, and then that term squared. Well, b in this one is a 10, so I would say 10 divided by 2, which you guys probably know what that is, but 10 divided by 2, and then we square that. Well, 10 divided by 2 is 5, and 5 squared equals 25. So 25 is what I'm adding to both sides to complete the square, okay? Now, the reason that we do that is because this term here is now a perfect square trinomial, and the factor of it is x plus 5 squared. That's x plus 5 times x plus 5. It's the factors of 25 that equal 10. It's 5. So once you find half of your b divided by 2, that's the term that goes here. X plus 5 squared is the same way as how you write this, or you factor it. Okay, now that equals, on the right side, negative 8 plus 25, or 25 minus 8, which is 17. All right, now what we can do is we can turn this into the vertex form. But in order to do that, we need this 17, or we need to remove the 17, which is to subtract 17, so that we have nothing over here, but that means we would have to subtract 17 from the left side, where there's nothing really to subtract it from, but we would end up with x plus 5 squared minus 17 equals 0, and now we just write it in vertex form. That's y equals x plus 5 squared minus 17. So now that is our vertex form, and that's what we would put in our answer. That's x plus 5 squared minus 17. Okay, so in this example, this is giving you, again, an equation in standard form, y equals x squared minus 6x plus 21. It wants the vertex form and the actual vertex. All right, so We're going to start, again, by writing this as an equation. So x squared minus 6x plus 21 equals 0. All right? Again, if you were trying to factor this, there's no factors of 21 that equals 6. So we would need to complete the square. But we can also complete the square to write it in vertex form, which is what we're trying to do. So I'm going to use the ax squared plus the bx to complete the square. So I'm going to remove this negative 21 from the left side. I'm going to subtract 21 to cancel it, but I have to subtract 21 on the right side to keep it equal. So now I have an equation x squared minus 6x equals negative 21. And then to complete the square, I'm going to add a term to both sides. So I use these boxes to identify that, and I'm adding to both sides. And again, the term that always goes in here is always half of the b term squared. So again, if I think of that, not negative b, but b divided by 2, or half of b squared. And again, in this one, b is negative 6. So if we plug in a negative 6 and we take half of it, and then we square it, negative 6 divided by 2 is negative 3. So we have negative 3, and then we square it. Well, when you square a negative 3, you get positive 9. So we're adding 9 to both sides of the equation. Because I added 9 to both sides, I keep it equal. And over here, I turned this into a perfect square that can be factored, or the factors of 9 that equal negative 6 are negative 3 and negative 3. So it's x minus 3 squared. This minus 3 is what goes in this factor right here. And that equals negative 21 plus 9 is negative 12. Okay, and then to write it in vertex form, we're basically going to be bringing this negative 12 back over, or maybe the better way to say it is we're going to add 12 to cancel it over here, so we have to add 12 on the left side. But again, when you bring this over to the other side of the equation, it changes the sign. But we can now write it in vertex form. Y equals x minus 3 squared plus 12. And then in this form now, you have the actual vertex. The vertex is the HK. So the vertex is here, or I should just put it's here and here. So it's 3 is the x value, and the y value is the 12. Okay, this one doesn't change. Okay, so remember, inside the parentheses, we shift right or left. A minus 3 actually shifts it to the right 3 units, so we end up at positive 3, and this 12 shifts it up or down, but it's exactly what it says, positive 12. So our answer for this one, the equation, the vertex form of the equation was x minus 3 squared and then plus 12. And the vertex is at 3, 12. 3, 12. All right, that's a couple examples that hopefully will help you with this assignment.